was to do kind of a guessing game, sort of like what we had done, except instead of generating a random number and having them guess, we're having them we're generating a formula, presenting the formula to them. They have to come up with the answer. They submit the answer. If it's right, we give them a point. If it's wrong, we don't. Maybe ask them ask them 10 times or something like that. Okay. So let's do that. Just for the sake of space, let's just dump our play guessing game. Just get rid of all that. Okay, so here's our play guessing game. Very first thing we need to do is we're going to start off again in baby steps. So we want to call our formula, build formula, and generate a formula. And we'll go ahead and put that in a variable, and then let's display that. Okay, start with that, but we're going to do that inside of our function. So we'll set a formula equal to whatever's returned by build formula. And build formula, what, gives us a formula in the range of 1 to 1,000? Is that right? Oh no, that's our original number. How many are we building? Oh, between 1 and 100, right? So let's make that a little, for our guessing game, let's make that 1 to 5, so we can quickly do the math. Okay. So build formula is going to build a formula, set it to a formula. Notice that we're calling another function inside of a function here. And then we want to go ahead and we want to print that formula, just proving that all that jazz worked. So we're going to print the value in a formula. Okay, and let's see what that looks like. We should just get a single formula. So there's our formula. Run it again, should get a different formula, so on and so forth. Okay, so now we want to go ahead and ask the question. What's the answer? Here's the formula. What's the answer, right? So we're going to prompt get this stuff out of here. We're going to have a variable for our answer. Oh, that's going to break stuff, right? So we'll set answer equal to, we're going to prompt for a number, which should be our answer, correct? And the message that we want to give them is a formula, the math problem we want them to solve, correct? You know, we could be nice and say, please enter the answer for this, but we're just going to give them a math formula. All right, we kind of know what's up. We stored the answer inside of answer. Now, actually, let's rename this a little bit. Let's call this user answer. Okay? Then we want to actually calculate the actual answer. So let's give ourselves another variable. Actual answer. The actual answer is going to be whatever doMath returns, passing it our formula. Make sense? So now we're generating a formula. We're showing the formula to the user, reading in their answer as a number. Then we're generating a variable called actual answer that's going to store the actual answer of that. And then we want to compare the two. Did the user enter this correctly or did they not? Okay. That's going to be some logic. If statement. So we want to say if the user answer is the same as the actual answer. The user answer is the same as the actual answer, then we're going to print correct. Otherwise, whoa. Oh. Wrong button, wrong star there. Otherwise, we're going to say wrong, the correct answer was, and then we want to actually show them what the correct answer is. So to do that, we're going to go into text, and we're going to create text. We're going to create text with this guy and actual answer. So we're going to say wrong, the correct answer was, followed by a colon, whatever the actual answer was.
We have to do that, what the right answer is.
We don't have to. I'm just rating a game. You know, like we proved last time, any game, I'm not going to ever get into this else if I'm playing it.
Yeah.
Right? I don't even have to have the monitor on, actually, to win this game. Because I went into full savant mode last class, right? Did I get 3 in a row one time?
4.
4? I think I got 3 in a row. 4 total. It was ridiculous. Just ridiculous. Did you say it was a 1 in 10,000 chance?
1 in 1,000.
Huh?
1 in 1,000.
1 in 1,000? Oh, that was 1 to 10, right? Yeah. Okay. So, play guessing game. We're going to generate a formula, read in the user's answer, figure out what the real answer should be, ask a question. If the two answers match each other, print out correct. If they don't match each other, we're going to print out wrong. The correct answer was whatever the actual answer was. Makes pretty good sense? Now again, at this point in time, this is an untapped resource. I haven't actually called this function. I've just written the function. So now we want to go ahead and call our function. Did I still name it guessing game? Play guessing game, that's fine. All right, so it's going to give us a formula. Very good. And I'm going to guess that that's 421, which will certainly be wrong. Okay. Not even large enough to meet the first number. So we should get a wrong answer here. Wrong. The correct answer was 2,746. Perfect. All right. Now let's try it with a, oh, that's still printing our, oh, we're calling it twice. That's what happened. All right. So now let's get it right. All right, so we have 372 plus 6, row, 630, 793, 697, 793 plus 697, huh? Oh, I meant to do, I was testing you. Okay, 2,492. 2,492. Correct. All right. So now we have the logic for reading in a single answer and testing to see if that answer was right, printing out whether it was right or wrong. Okay? But now what we're supposed to do for the homework is actually ask them 10 questions Did I say 10 or did I say like 3? 10? Okay. So 10 questions. Man, it's going to suck having to enter in that much math.
We just shortened ours to like 2.
Well, I'm going to go even better than that. I'm going to have it print out what the answer is before each one, so I know the number. Okay, just for testing purposes, of course. You know, it's just for testing purposes, of course. Now, actually, here's the good thing. The good thing is that whether you know it or not, the fact that you guys are starting to get jokes related to code means you're starting to think like a programmer. When you get into these later computer science courses, we actually insert things in our code, comments or variable names that are funny, and the audience gets it. Once you get to that point, all is lost. Okay, you've gone down, you're completely over on the dark side. The fact that you're starting to get the programming jokes is sad, really, actually. Any of you dream in code yet? Have you worked on a homework assignment so long that you actually had a dream about it? So I would say in the 300 class, which is 2 classes from now, the average homework assignment, that's a pretty advanced programming class. The average homework assignment probably takes them, I don't know, somewhere between 3 and 10 hours, something like that. They work in groups, that kind of stuff. But some of the assignments are pretty difficult. The last 2 actually probably only took about 10 minutes if they had learned the stuff. But several of them have told me that they like wake up in the middle of the night with like a new idea for a solution, and I guess that's kind of pathetic as well. So you have that to look forward to, as I guess what I'm saying. Okay, so in any case, we want to now do this some number of times. We said we're going to do it 10 times, right? Okay, well, how do we do something 10 times? Well, we need a loop. So we're going to repeat something 10 times. We're going to do all this crap 10 times. We can go ahead and print out the answer so they know whether they got it right or wrong. I am going to, however, throw a little print statement up here. After I get my answer, oh here, right before that. So actually, I then need to oh my gosh. I just had to create my variables in a little bit different order. So build the formula, get the actual answer. Then I'm going to print out the actual answer so I know what it is as the user. I'll pick and choose when to get it right and stuff. So I'm going to print out the actual answer. Then ask the user for their answer after they've already seen the answer. Then do all this other jazz. Okay? But before we even start that loop, we need to keep track of a score. Okay? We need to keep track of a score. So I'm going to need another variable before the loop. We're going to call this guy, let's call it numWrite. This is the number of questions you've gotten right at this point. And we'll start it off at 0 because we haven't gotten any questions right. Each time through, if they get it right, we'll print out correct. But we also want to set numWrite equal to numWrite plus 1. All right, so if they get an answer right, set numWrite equal to whatever it currently is plus a 1. All right, it's going to do all this 10 times. After the loop is done, what are we going to do? We're going to calculate a percentage for the number right they got, correct? Mm-hmm. All right, so we're going to print this is after the loop, but inside the function. And we're going to print some text built out of multiple things. So create text with you answered num correct or num right. Questions for a score of, and we need to calculate the percentage. The percentage is going to be number right divided by 10 times 100. So math. Oh, that's not the right one. Math. More math. Divide. Num right divided by 10. It's also starting to bother me that I'm getting fairly fast at writing this Blockly stuff. It's like speed puzzles. Num right divided by 10 times 100. All right. And then we might choose to round that, but let's just see what that looks like. Okay, so exact same thing we did before, except now we're keeping track of one additional variable, the number they answered right. We're doing all the question stuff 10 times. We've added one additional thing. Whenever they answer something correct, we add 1 to number right. Then after we've done this 10 times, we're going to print out some text that we created with these 4 pieces. You answered. Uh-oh. You answered, followed by num right, questions for a score of, and then whatever their percentage is. We actually could probably, just so we know that we are, well, this is what the cool kids would do, I guess is what I'm saying. Put the little percentage sign after it, right? Okay, so let's go ahead and play our game. And actually, just for our first test, let's just do this 5 times. Okay, and remember, we are cheating. All right, so 3285 is our first answer. So we're going to say 3285. We get a correct, and we just got a point. Next one, 1424. I'm going to get this one wrong. Wrong. The correct answer is 1424. 1252. Let's get that one right. Correct. 1507. We'll get that one right. Correct. 3501. We'll get that one correct. I answered 4 questions for a score of 40%. That's not right. Oh, because I'm dividing by 10. Dividing by 10. So 80%. It is right. I did that on purpose because it's actually an important lesson. So what I'm going to do here is I'm going to create another variable called num questions. And we're going to set this guy, in this case, equal to 5. And then instead of repeating something 5 times, we're going to repeat it num question number of times. Similarly, we calculate our percentage down here. We won't divide by 10. We'll divide by num questions. Play this again. 1386, 1386, 1821, 1821, 1654. Let's get this one wrong. 1675, 1149, and there's our 80%. Make sense? All right. So this is a reasonable. Does that solve everything for the homework? Okay, so that's a reasonable solution for the homework assignment. Okay, so now that we have that, I'm going to actually steal this code. So we want to start something a little new today. And look at all that XML. All right, saved. So with that in mind, I'm going to refresh this page. The first time in days. Brand new project. We're going to create a card game. All right. So when we think about cards, so what we're actually doing is we're kind of stumbling into almost the recreation. I know this is the wrong course here. Stumbling into the recreation of the problem that we ran into between C and C++, these older languages. Kind of the advent of object-oriented languages from procedural languages. Remember way back near the beginning of the semester we talked about kind of the telephone example? That guy? Where we have the procedural telephone as the pile of wires, and the object-oriented telephone actually looks like a telephone. Well, languages like C++, C#, Objective-C, Swift, Java, all these newer languages, they all support objects. We look at Blockly here. We don't really have a way of supporting objects. You can actually pull it off in Blockly because Blockly allows you to create your own custom blocks, but we're not doing that. We're going to pretend like we're the C programmers who had to start forcing the language to do some things that it wasn't built to do. All right, so we're going to add a slide. So when you play cards, so you got a deck of cards, and you're flipping through it, you pull out a random card. What is a card? What pieces of information go on a card? Okay, suit and number. At the very least, those two things. For certain card games, you might want to also keep track of the value, right? Because like, for instance, aces sometimes have two different values associated with them, stuff like that. But let's just start off with the suit and the number. Suit and the number, it's on there. Or the suit and the display value, let's call it that. So we have suit, is there an E on it? 2 E's, 3 E's?
I think 5.
5 E's. And display value. Okay, so for instance, we might have clubs, and we might have 5. So the 5 of clubs, so on and so forth, right? What kind of construct do we have? So let me actually create another page here. So we want the 2 of clubs. We want the 3 of clubs. We want the 4 of clubs, so on and so forth, right? Then the jack, queen, king, ace of clubs. And then we want that for the other 3 suits. Now, what kind of construct do we have in Blockly that would allow us to represent a single card? Excuse me. List. List would allow us to represent a single card. List with 2 items in it. 1 item for the display name and 1 item for the suit. Okay, so we can create lists that hold 2 things. And we just have to remember that the first thing is the display name and the second thing is the suit. We have to remember those 2 things, okay? So what we're going to do here is we're going to start off by creating a variable. And just because we want to keep this simple, we're just going to create a single card. Just kind of proof of concept here. And our single card is going to be a list. This list is actually only going to contain two things, so we can take one of those guys off. And it's going to contain two pieces of information. Display value, so let's say this is the 2. And a suit. 2 of clubs. All right. We're actually getting, do I have that in here? That's a shame. There's actually a Blockly block that allows you to do pictures. So we can actually have a picture of clubs, but we might go that route later. All right, so we're going to create a single list where bucket 0 is the 2, bucket 1 is clubs. And we have a card. Now we want to go ahead and display a card, but we want to display it in an interesting way. We don't want it to just say 2 in clubs. So I mean, just for right now, let's just do a print just to see what it would look like right now. And we'll just print the value of a card. There's 2 comma clubs. We'd really like it to display by saying 2 of clubs. Correct? That's kind of what we'd like it to look like.
The delimiter thing.
Okay, we could. Okay, but we know that this list has 2 buckets. Index 0, index 1. We know that's the case. This just happens to be how it printed out a list in JavaScript. Couldn't I do this? Couldn't I say print text? We really want 3 items in here. We want the first, well, here, we want the second item to be of. So let's say space of space. And we want the first item to be the first element of a card. And we want the third item to be the second element of a card. So 2 of clubs. So we'll go under lists. In list a card, get position 0. Actually, isn't it 1? 1 based. And then get position 2. Now we print this out, we get 2 of clubs. Make sense? Now, wouldn't it be nice if I had a little function I could call that I could just pass a card to and it would display that card for me? Okay, so I'll go ahead and create a function. We'll call this guy display card. And display card is going to take a single input. And he's going to take in an input called a card. Actually, just so we don't get things confused, let's just call it C in here. And what we're going to do is we're going to take that stuff and we're going to have it display C. So here's my function to display cards. I can create a card here, and then I can go ahead and call display card, passing it a card. And I'll get the same output, 2 of clubs. Now I actually don't need to put that card in a variable if I don't want to. I can actually just pass this directly. So I can say display card, this card. This is how we build a card, right? A card object, even though we don't have objects yet, a card object is 2 elements, a value and a suit. So this will display 2 of clubs. Similarly, I can display 3 of clubs. So I'm calling that method 2 separate times, that function 2 separate times, passing it 2 different cards. There's my 2 of clubs. There's my 3 of clubs. Make sense? Go ahead.
Is there a way that you can, I don't know, put a list and then randomize the list for the cards in the sense of...
Oh, for like shuffling a deck? Yep, we're going down that path. Yep, there is. There is. I don't know if I'm going to be solving it or you're going to be solving it yet, but yeah, there is. You'll have to write the logic for it. Okay, but for starters, what I'd like to do is I would like to display all of the cards between 2 and 10 of clubs. Make sense? But I don't want to do this 10 times or 8 times. I want to use a loop. I want to repeat this over and over again. Okay? But I want to build different cards each time. So I'm going to need a loop. I'm actually going to use a counter here. I'm going to start my counter off at 2. I'm going to go up to 10. I'm going to display a card. Instead of a string there, I'm going to display I as my face value. Two of clubs, 3 of clubs, 4 of clubs, 5, 6, 7, 8, 9, 10 of clubs. Make sense? Now I'm generating all the clubs. What about the Jack, Queen, King, and Ace? That doesn't really become a counting problem, does it? Jack, Queen, King, and Ace become more hard-coded type problems. So do I then just create 4 more cards after this? Display Jack, clubs, Queen, King, Ace. I could do that, right? This is pulled off. So this goes through all the numbers between 2 and 10. And then we go and do these. Let's just look at this real quick, and then it's 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King, Ace. Go ahead.
Couldn't you use the loop for? Couldn't you create a list with Jack, Queen, King, Ace in it, and then use the loop for each item, J and list, whatever?
Okay. Couldn't I create a list that has 2, 3, 4, 5, 6, 7, 8, 9, 10 Jack, Queen, King, Ace in it, and then use the same loop you referred to? Okay. So what he wants to do, we'll keep display card up here, is he wants to create a list. Throw it out here. And we'll just steal this real quick. Three, 4, 5, 6, 7, 8, 9, 10, 11. Well, Jack, Queen, King, Ace. And we're going to call this guy the display values. Throw that guy in there. So let's just get rid of all this stuff. It's just in the way for the moment. So we're going to have our display values, and our first display value will be 2. Let me just paste them all in here first, and then we'll update them. All right, so we have a list of display values. Make sense? And now he wants to create the loop that goes through every element of a list. So here's a loop for each. Let's just rename this, and let's call this guy each display value in our list called display values. The display values for each of those guys. What are we going to do? We're going to display our card. And we're going to display what card? We're going to display the card that is the list created with our display value. And for right now, the string clubs. And we'll remove one of those guys, so we only need 2. So we built up our list of all of our cards, 2 through 10, then Jack, Queen, King, Ace. Then we're going to loop through every element of that list. So for each display value, we just create a variable called display value in the list of the display values. We're going to display the card. What card? The card created from the list display value and clubs. What time does class get out? 50, oh, we got 6 minutes left. Just some people are packing. Okay. I was just making sure I wasn't going over. My clock was right here. Oh, yeah, no problem. No problem. Don't sweat it. It's cool. Everything's cool. All right, and we got to connect these guys because these guys are all part of our main program here. Okay. Then what we're going to do is we're going to run this, and it should show us all of our cards. 2 of clubs, 3 of clubs, 4 of clubs, 5 of clubs, 6 of clubs, 7 of clubs, 8 of clubs, 9, 10, Jack, Queen, King, Ace. Now, would you agree we could do the same thing with our suits? Clubs, diamonds, spades, hearts. All right, so we're going to go ahead and we're going to have another variable. We'll set the suits equal to a list. And this list will have 4 items in it. Okay, so let's do diamonds, hearts, clubs, spades, all right. So now, for each value in display values, we want to do something for all the things in the suits. So I'm actually going to wrap this guy inside of another loop. I'm going to say for each we'll rename this guy suit name in our list called the suits. Do what? For each display value in the display value. So this is a loop inside of a loop. So 4 times we're going to do something. What are we going to do? We're going to print out every single card. So instead of hard coding clubs here, we're going to put suit name. Make sense? So now we have, unfortunately, here's all of our diamonds. Okay, Ken. There's all of our hearts.
It'll automatically enter them once you get to the end. If you click enter one too many times, it starts.
Well, we're seeing them. We're seeing them, right?
Yeah.
Here's all of our clubs. And here's all of our spades. Make sense? All right. So that's displaying those cards. Now, really, we'd probably like to add those cards to something called the deck instead of displaying those cards. So I can now create a, let's do that for our homework. It'll be an easier homework assignment. Give you a little bit of a break. So what you want to do is you want to create an empty list. All right? And then what you want to do is you want to add stuff to that list. So you'll set bucket 1 as being 1 card, bucket 2 as being another card, bucket 3 as being another card. Now, how do we represent a card? It's a 2-element list. So this will end up being a list of 2-element lists. Make sense? Okay, that'll be called, you can call it the deck. It's probably what makes the most sense. So I'll give you this as a starting point. And what you need to do is instead of printing out all the cards, go ahead and load all the cards into a deck. Then it would probably be beneficial for you to go through and print all the cards and make sure that they accurately got loaded into the deck. Okay, make sense? So we're on our way to making a card game. All right, I will see everybody on Monday. Have a good weekend.